So we have some matches here that have been put together, and we call the first figure number 1, and we can see that there are 3 matches. Okay. Then we've kept the first 3 the same, and then next time around we've added another 2 matches. So figure number 2 has 5 matches. Figure number 1 had 3 matches. We can see that figure number 3, we've added 2 matches again, and in figure number 4, we've added 2 matches again. So we can see that there's a pattern. Figure number 3 has 2 more matches, so we get 5 matches. Figure number 2 had 2 more matches than in figure number 1. Whoops. 5 plus 2 is not 5, 7. And figure number 4 would have add 2, 9 matches. Let's just check that we've done it all right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 matches. So we've seen the pattern. And this pattern here is very important for us. This one is the difference. And the formula for finding the sequence of the series, finding the pattern or the sequence, it's got a really nice formula. And we say that it is the difference between each of the patterns multiplied by n. So the difference between the patterns. And this only works if it's always the same number. If the difference between the patterns is always one number, like here it's plus 2, plus 2, plus 2, we can put that number in front of n. But if we were to write, if we were to multiply 1 by 2, so it would mean that what we'd be doing here is we'd say, we'd take 1 and we'd multiply it by 2, because 2 was the difference. Is 1 times 2 going to give us 3? No, it isn't. So there's something else missing here. And this is what we call here, add to this number that we get, the difference, which in our case would be 2 lots of n, because our difference would 2, plus the start number will give us our real formula. And what do I mean by the start number? Well, here we're starting with figure number 1. If we were to take this one step back and go to figure number 0, figure number 0 here, how many matches would there be if we went one step back? Well, here we've been adding 2 all the time. So what we'd do from here is we'd go 2 backwards, we'd take away 2. Our starting number here would be 1. So for our figure number 0, we would have 1 matchstick, because this would give us the pattern we want, that we're adding 2 each time. So our starting number would, in our case, be plus 1. Now we have our formula for any sequence. So we take the difference, which is the number between each of the figures, plus 2, 2 lots of n, plus our starting number, which we go one step back from figure 1 and make a pretend figure 0. Figure 0 would have had 1 matchstick, so our formula is going to be 2n plus 1. And this method works for all series and sequences where there's a constant number being added every time. So think of the difference between the pattern, multiply it by n, and add 1. So the first question here was, how many matchsticks would be in figure number 6? Figure number 5 we know would be just plus 2. Would be 11, and figure number 6 we know it would be plus 2 again. So we're expecting it to be 13. Let's prove that using our formula. We know that for figure number 6, n equals 6. N is actually just the figure number. So how many sticks? The sticks will be equal to 6 times n plus 1. So here we've got that the number of sticks is 2 times the figure number plus 1. Let's put in figure number 6. N equals 6. Whoops, 2n plus 1. the number of sticks should equal 2n plus 1, but we know that n equals 6. So wherever we see n, we replace it with its real number, which is a 6. So equals 2 times 6 plus 1. 2 times 6 is 12. 12 plus 1 is 13. So we were expecting 13 when we looked up here. We got 13 when we used our algebraic formula, 2n plus 1. And you can have used either ways to get the point. So now we've actually checked that our formula works. So this was part B to work out the formula. So this was part A to work out how many sticks there were. There would be 13 sticks in figure number, and don't forget to answer the question properly, in figure number 6, there would be 13 sticks. Then the next formula was, okay, if we have 121 sticks then, what figure number has 121 sticks? Well, we have a formula for our sticks and our figure number. We know that sticks is the same as 2n plus 1. N's the figure number, and that's the one we don't know. But we do know the number of sticks, so we put the real number of sticks where we see the word sticks. So 121 equals 2 lots of n plus 1. We want all the letters on one side and all the numbers on the other. So if we want to get rid of this plus 1 here, we can do that. We can take away 1 from both sides. We're allowed to do whatever we want in maths as long as we do the same thing to both sides. If I was to take away 1 from both sides, I'd get 121 minus 1 equals 2n plus 1 minus 1. Here I've taken away 1, and here I've taken away 1. Everything else is the same, so I'm allowed to do that. Okay, what is 121 minus 1? That's 120. What is 1 minus 1? It's 0, and this is what we want. We wanted to get rid of that silly little 1 there, because it was on the wrong side. It was on the same side as letters. Numbers and letters aren't supposed to be on the same side. So this gives us 0. So we know that 120 equals 2 lots of n. So if 2 lots of n equal 120, you can see it, can't you, that if 2 lots of n equals 120, then 1 lot of n would be half of that. But the maths way of showing it would be to divide both sides of the equation by 2. I don't want any numbers here. I want n by itself. If I divide 2 by 2, I get n. Because 2 divided by 2 is 1. So I get 1 lot of n equals 120 divided by 2, which we know is 60. So in figure number 60, there would be exactly 121 sticks.